Hello friends, good morning. So today we will continue with our session. Yesterday's session we will continue today. Yesterday we are done with probability basics. Some part of the basics are still left. We'll continue with that. We'll complete that basics and we'll go to a very important topic, that is axiomatic approach to probability. Okay, let us get started, friends. So we were discussing probability basics for IIT JAM and GATB. So before starting the session, let me reiterate again. So we are starting a course, that is secure below AIR 100 IIT JAM Biotechnology in Feb 2025. Okay, the course fee is, it's almost 22,000, that is 22K, rank assurance program. Okay, so what is the USP of this program? It is a well designed 6 months plan. Okay, it will be having interactive live and recorded sessions. In case, by any case, you can't attend a live session, you can also watch recorded sessions. For our working aspirants, I'm telling. And well crafted PPTs you will be get. That is the hallmark of Chandu biology classes. Our notes are one of the best in the market. Okay. Next, expert designed study material. Our study materials also, the quality speaks for themselves. And 13 chapter wise and 10 mock tests. Okay. And individual attention will be given to every student. That those students who are already enrolled in the course in previous courses and all, they will be knowing how Dr. Chandrasekhar sir is with students every time when they have the doubts or any what query or any confusion they have, it will be immediately resolved. Okay, he is very much accessible to you. Okay, this course will be starting from 1st October. Remember the date when it is starting from 1st October. So enroll as soon as possible and get started. Okay, with right enthusiasm and right intent from 1st October itself, so that you don't miss any classes. All right. Next thing is, similarly, we have a course secure below 100 rank. Okay, in GATB and Common University Entrance Test PG 2025. So the USP remains the same, but this is for GATB exam and Common University Entrance exam. And here also the fees remains the same, that is 22,000, and it will be monitored by Dr. Chandrasekhar sir itself. This course also contains mathematics required for the exam. Only pertaining to the exam, and similarly for IIT JAMB. Okay, when it comes to core paper, it will be covered by Chandrasekhar sir, Dr. Chandrasekhar sir. Okay, who is a PhD from Indian Institute of Science. Okay, friends, let us get started. So in the yesterday's class, we discussed about certain basic terms associated with probability, like trial, outcome, sample space. What is a random experiment? Okay, what is a random experiment? Next, event. What is an event? All these things. So today we have to do what is mutually exclusive event, exhaustive event, and partition of sample space. So these are the basic things that are left out from yesterday's session. We have discussed what is an event. Event means what is the output you get, what is the actual final result you get, that is called event. So out of those events, there are two types. That is, one is mutually exclusive event and exhaustive events. In the upcoming classes, we'll be covering even what do you mean by independent events, what do you mean by dependent event, and all these things. But in today's session, we'll be learning only two types of event. That is, what is mutually exclusive event, and another one is exhaustive event. What is mutually exhaustive event? Okay, these are very important. Next is, what is partition of sample space. So without no further ado, let us get started. After completing these topics, we will move to very important concept, that is axiomatic approach to probability. In probability, on an average, you will get one or two questions. On an average, I can say two questions in every exam related to IIT JAM or GATB. And statistics also, you will get on an average two questions. If I say of probability, out of probability topics, from which topic, which topic the questions can come, or questions have come repeatedly, means I can say it has come repeatedly from axiomatic approach to probability. So that is a very high yielding topic and a very important topic. Okay, friends. So before that, we'll complete the basics. That is, we have to do what is mutually exhaustive event and mutually exclusive event. So let us first start with mutually exclusive events. The word itself says it is exclusive. Exclusive means it is unique to that, not related to another. So those events whose intersection is empty. Okay, those events whose intersection is empty. Intersection means what? Yesterday itself I told. Intersection means something that is common. Okay. Something that is common is called intersection. Intersection means something that is common. So intersection is empty means there is nothing common between two events. Suppose there are two events, there is nothing common between them, then we call that the intersection is empty. So the intersection of the events is the null sets. Intersection of the events is a null set means there is nothing common. Nothing is common. Nothing is common between two events. Two events, let us say E1, event 1 and event 2. Okay, so there is nothing common when it comes to two events, that is E1 and E2. Okay, all right. So let us say example tossing two coins, okay, and getting one event is getting both tails or both heads, and another event is getting both tails. Okay, getting both tails. Okay, friends. So event one tossing two coins. Event one is what? Event one is getting both tails. Getting both tails. Okay, all right. So what is the favorable outcome here? Here we are having getting both both tails means it should be just a minute. It should be first is getting both heads, right? First event is getting both heads. Both heads is H and H. Event two is getting what? Getting both tails. Okay. First is getting both heads. Now it is getting both tails. So how do you represent that? It is T and T. T and T. Got it? It is T and T. Got it. So now, if you see, is there anything common? Is there anything common between event 1 and event 2? No, nothing is common. Right? Here we have HH, here we have TT. Here it is not having HT or TH. Nothing is common. So I can say that E1, E2. Okay. Intersection you will represent it like this. It is a null set. It is equal to phi. Phi is nothing but null set. Okay. Or you can say it is null set or empty set or void set. Everything means the same, that is nothing is common. So therefore since it is a null set, therefore I can say E1 and E2 are what? Mutually exclusive events. Or what, friends? Mutually exclusive events. Mutually exclusive events. So therefore E1 and E2 are mutually exclusive events. Okay, now let me draw a tree diagram to explain. If you toss two coins, what are the possible outcomes you may get? See here. Suppose I toss two coins. Okay, so this is the coin. First, when I toss a single coin, I'll get head or tail. Correct? No. If I toss another coin, what are the possibilities I'll get? I can get head, right? I can get head and head. Another possibilities I can get head and tail. Now, if I toss another coin, I'll get how much? What are the possibilities I'll get? I can get tail and tail or tail and head. Okay, so these are the possibilities. These are the possible outcomes, total possible outcomes when it comes to tossing two coins. Tossing two coins. Okay, so this is what, friends? This is, we call it as tree diagram. In mathematics, we call this as tree diagram. Okay, so this is about tossing two coins. Next, we will take one more example. We'll take one more example to learn more about mutually exclusive events. Example is getting at least one net. Okay. Example is getting at least one net. E1. Okay. Event one is getting at least getting at least one head. Getting at least one head. Okay. When tossing two coins. Two coins are tossed. This is unbiased coin. Unbiased coin is also called fair coin. Okay, fair coin means which is having both head and tail. Biased coin means it is not a fair coin because both sides you are having head and head, or both sides you may be having tail and tail. So whenever we are talking in probability, we are talking only about fair coin, or it is also called unbiased coin. I explained in the previous class what do you mean by biased coin and unbiased coin. So when two coins are tossed, event one is getting at least one head. Okay, let it be event one represent, let it getting at least one head. So at least one head means one or more. Okay, one or more. It is not at most one head. At most one head means maximum you can get two heads. That's all. At least one head means one head followed by any number of heads. So at least one head means here it will be H. Another one will be H. One head followed by another head, or one head followed by tail, or tail followed by head. Okay, these are the possibilities. Okay, now event two. Event two, when the same two coins are tossed, okay, getting at least what? Getting at least one tail. Getting at least one tail. So at least one tail means I can write TT here. Okay, and it can be tail and head or head and tail. Now, if I see E1 and E2, is there anything common? Is there anything common? Definitely here there is nothing common. But if you see here, this and this are same and this and this are same. So that's why there is common here. There is something common between E1 and E2, that is T and H. T and H is here also, T and H is here also, here and here. And H and T is here also, H and T is here also. So there is something common between E1 and E2. That's why I can say that E1 what intersection E2 is what is not equal to null set. Phi means null set. Therefore, I can say that E1 and E2 are what? Are not are not mutually exclusive events. Are not what? Mutually exclusive events. Are not what? Mutually exclusive events. Okay, friends. So this is it about mutually exclusive events. So suppose there are two events happening. If there is nothing common between the two events, if it is a null set, then it is called mutually exclusive event. If there is something common between the two, then intersection means common. Okay, if there is something common between the two, we can say that they are not mutually exclusive event. That is the current example which I gave. Okay, so let us now move forward to learn about what do you mean by exhaustive events. You can either call it as exhaustive events or mutually exhaustive events. Both are one and the same. If the union of the events is a sample space. Union means if you combine the events. Okay. If you combine this is event 1, this is event 2, this is event 3, this is event 10. If it comes up to be sample space. Okay. If this comes up to a sample space. So for that, I'll give one more example. Suppose single coin. Single coin is tossed. Okay, what is the sample space? Sample space is what are the possibility that you can get? That is, you can either get head or tail. So this is the sample space. So here in this example, event one getting a head of tossing a coin, off or on tossing a coin. Event one is representing what? Head, getting a head. Okay, so similarly, event two is representing getting a tail, getting a tail. Okay. Now if I combine event one and event two, this is called union. This is called intersection. Okay. Intersection we use when we talk about mutually exclusive events. Union we use when we talk about exhaustive events. Please remember this. Intersection we talk when we talk about mutually exclusive events. And union we use when we talk about exhaustive events. Got it? So event one and event two. Look at this now. Event one and event two union. Event 1, what do we have? H. Event 2, what do we have? 2. I mean T, tail. So this is equal to what? Sample space. You can see here, this is the sample space here. This is the sample space. This is same as this one. This is same as this one. So when event 1 union event 2 is giving a sample space, then we say event 1 and event 2 are what? Are what? Mutually or just exhaustive events. Mutually exhaustive events or mutually or just exhaustive events. Exhaustive events. You can call it as what, friends? You can call it as mutually exclusive events previously. Now it is called mutually exhaustive events. In the current scenario, union U1, union U2, if it gives you sample space, it is called simply exhaustive events or mutually exhaustive events. Okay, got it, friend? Mutually exhaustive events. So this is it about exhaustive events. Now question is, in the given events, event 1 and event 2, are they mutually exclusive? Are they mutually exclusive? Okay, please observe carefully. Are they mutually exclusive? Is there anything common between event 1 and event 2? Think for a second. Are they mutually exclusive? Are they mutually exclusive? My question is, are they mutually exclusive? In the given example, is the given example mutually exclusive also? See here, I'm asking, are they mutually exclusive? That is my question. Okay, see, event 1 and event 2, anything common? Anything is common now? No, nothing is common. So I can say that here, event 1, intersection event 2, nothing is common. So this is a null set. So this is what? Definitely mutually exclusive event. Okay, so two events can be both mutually exclusive also, mutually exhaustive also. Okay, but it need not be necessary all the times. Okay, there is a possibility that two events can be mutually exclusive but need not be exhaustive, or two events can be mutually exhaustive but need not be what? Exclusive. Okay, don't get confused. But in this example, okay, in the current example, this unique example, we are getting both the cases. It is mutually exhaustive also, mutually exclusive also. So one thing you must understand, I am repeating the words again. Mutually exclusive means you look for common. Mutually exclusive, if it is common, if there is something common, then it is not mutually exclusive. If nothing is common in the intersection, even intersection E2, there is nothing common, or if it is coming as a null set, then we call it as mutually exclusive events. Next, coming to exhaustive events. In exhaustive events, what you should remember, friends? Union of events. Union of event means you combine the given events. If you combine the given events, if it comes out to be a sample space of the given experiments, sample space of given experiments, then we say that it is what? It is exhaustive events. Okay, so in the exhaustive events you are talking about union, in the exclusive events you are talking about intersection. So one more example I can give for exhaustive events. Exhaustive events. See, suppose rolling a dice or throwing a dice, rolling a dice. Okay, sample space is what? We get 1, 2, 3, 4, 5, 6. This is the sample space, correct? Now, suppose event 1, unrolling a dice, we get 1. And event 2, unrolling a die, we get 2. Event 3, we get 3. Event 4, event 4 we get 4. This is what I'm telling. Example for another example for mutually exhaustive events or exhaustive events or just exhaustive events. Event 5 I'm getting 5. Event 6 I'm getting what? Event 6 I'm getting 6. Okay, so now if I do what? E1 union E2 union E3 union E4 union E5 union E6, what do I get? I get, it is nothing but equal to, what do I get? I'll get equal to 1, 2, 3, 4, 5, and 6. And 6. So this is nothing but equal to what? This is nothing but equal to, friends. Just observe carefully. This is nothing but equal to sample space. Therefore, these are all what? E1, E2 union. I mean, E1, E2, E3, E4, E5, E6 are, or what? They are all exhaustive events. So in this case, are they mutually exclusive? Please write in the comment section. Are they mutually exclusive? In this experiment, I mean, in this example, are they mutually exclusive? Are they mutually exclusive also? Are they mutually exclusive? Are they mutually exclusive? Rolling a dice. Are they mutually exclusive? Please answer in the comment section. I want your answer. Okay. So I hope now it is clear to you about what do you mean by mutually exclusive events, mutually exhaustive events. Next, another important concept is partition of sample space. So in a question they can give, in an experiment having partition of sample space, they will give certain condition. What is the probability of getting something? Okay, they will give the condition. So at that time, if you don't know the meaning of what you mean by partition of sample space, you will not be able to get the answer at all. Okay, friends, that's why knowing the meaning or knowing the concept of partition of sample space is highly important, and it will be highly beneficial to you to solve many questions. Okay, so now let us discuss what is the last term when it comes to probability. Now we have to understand when it comes to basics of probability, you have to understand what is partition of sample space. Okay, what is partition of sample space? So if the two events or if any number of events are both mutually exclusive also and mutually exhaustive also, then they form a partition of sample space. Then they form partition of sample space. Okay, partition means you can understand. Indian subcontinent had many countries. Indian subcontinent has many countries. India, Pakistan, Afghanistan, Nepal, Bhutan, and all these things. Sri Lanka and all these things. So when you do partition, so Indian subcontinent partitioned into India, Pakistan, Afghanistan, Nepal, Bhutan, like this. That's the meaning of partition, dividing. Okay. So if events, suppose there are two events, E1 and E2. Okay. They are mutually exclusive also, mutually exclusive and mutually or just exhaustive also. Exhaustive. Okay. They should be both mutually exclusive and mutually exhaustive. Then E1 and E2 has partition of sample space. Then we can say that E1 and E2 has partition of sample space. So see here, friends. If you have two events E1 and E2 such that E1 intersection E2 is 5, that means what? E1 and E2 are even intersection E2, that is there is nothing common between them, that is null set. Okay, there is no commonality between event 1 and event 2, that is null set. So E1 and E2 are mutually exclusive events. Mutually exclusive events. Next, even union in union E2 forms a sample space, gives a sample space, then we can say that it is exhaustive events. Exhaustive events. Okay, exhaustive events. So that means what, friends? So if you have two events such that first condition, it should be mutually exclusive, and second condition, it should be mutually exhaustive or just exhaustive events. This should be both this also and this also. Then we say that event 1 and event 2 form partition of sample space. What is the example for this? Tossing a coin, tossing a single coin and getting head and tail. Okay, which we discussed earlier. If you get head in event 1, okay, tossing a coin. I'll give examples here. Okay, event 1. First experiment is tossing a coin. Tossing a coin. Okay. Event 1, getting a head. Getting a head. Without it is represented by like this H. Set of H. Okay. E2 is getting tail. Getting a tail. Or friends, E2 is about getting a tail. Event 2 is representing getting a tail. Is there anything common between them? Nothing is common. So I can say even intersection E2 is 5. Nothing is common. So that is even and E2 are even and E2 are mutually exclusive events, and even union E2. Even union E2. Tossing a coin, what is the sample space? Sample space is head, comma, tail. So here, even union E2, you are getting what? Head, comma, tail. That is nothing but sample space. So therefore, even and E2 are what? Exhaustive events. Even and E2 are exhaustive events. Okay. So here, therefore, here, even and E2, what? They form partition of sample space. They form partition of sample space. Okay, friends, that's it. So these are the basics which you had to learn. So we learned what is a trial. Okay, what is an outcome? What is a random experiment? Okay, what is a sample space? Okay, what is an outcome? What is an event? Okay, we also learned what is mutually exclusive event, what is mutually exhaustive event, and we learned what is partition of sample space. Having said that, so these are the basic terminologies that one has to remember when it comes to learning probability. Okay, so we have covered all the basics when it comes to probability. So next let us move to our important topic of discussion, that is partition of, that is partition of sample space is done. That is, we have to discuss what is axiomatic approach to probability. So this is very important, friends. Okay, that is axiomatic approach to probability. This is axiomatic approach. Okay, axiomatic approach. When it comes to axiomatic approach, okay, you're getting definitely you're getting one question. When it comes to axiomatic approach, how many questions you're getting? Definitely one question you're getting. Okay, friends, definitely you're getting how many questions? Definitely you're getting one question. Okay, when it comes to axiomatic approach, definitely one question. One question you're getting both in GAT-B and also IIT-JAM. IIT-JAM PT. Okay, so this is a topic of high important. This is what? Highly important, friends. So this topic is highly important. Okay, if you ask for probability, which are the topics you have to study? Okay, important topic. If I have to say, if you ask me what are the topics which I have to revise before going to the exam, I would say this topic first. Okay, that is the importance of this topic. Okay, so let us see what are the things that we have to cover when it comes to axiomatic approach of probability. So first thing, that is we have to cover what is probability itself. What is probability? And under this we have to cover even what is that? We have to cover not just probability, we have to cover addition theorem. Okay, that means we are not going to prove any theorem. What are the results of that theorem? We are going to use that in solving the questions. And based on this, what are the PYQs that has come that we are going to discuss. Okay, friends, this is when it comes to what? Axiomatic approach to probability. So this is a highly important topic and I want you people to pay complete attention. Got it, friends? You have to pay complete attention while learning this topic. Next is, I mean, we will learn what is probability. Okay, we will learn what is probability here. Okay, I think the slide is missing. Anyways, I'll tell you. Okay, here it is. See here, let E be an event. Okay, see probability. One thing you must understand, we are going to find probability of an event. We are not going to find probability of a sample space, probability of an outcome. No. Once the event has occurred, that is final result we have got. Based on that, we are going to find the probability. Probability of an event. Always we are going to find probability of an event. It is denoted by P of E. Okay, let E be an event. Then probability of an event E is denoted by what? P of E. P of E means what? Probability of an event. And is defined as what? Is defined as what? It is defined as this one. Okay, it is defined as this one. It is defined as this one. So probability of an event is number of outcome favorable of E. That is number of outcomes that are favorable to the events divided by total number of outcomes. Or in simple words, probability of event is number of number of favorable number of favorable outcomes divided by total number of outcomes. Divided by what, friends? Total number of outcomes. That is sample space. Total number of outcomes is nothing but sample space. Set of all possible outcomes, we learned. Set of all possible outcomes is what? Sample space. Set of all possible outcomes is sample space. Number of favorable outcomes divided by total number of outcomes. That is probability. Probability of an event is number of favorable outcomes. What outcomes? Not just favorable outcomes, number of, okay, number of favorable outcomes divided by total number of outcomes. Okay, so that is the meaning of probability. Before going to addition theorem, I'll give you one example about how to find probability. Suppose let the event be let the event be let the event be getting a head on example. Okay, getting a head on tossing a coin. Okay, let the event be getting head on tossing a coin. So probability of event is given by number of favorable outcomes. Okay, so number of favorable outcomes. Okay, before that, let me write. First, I should tell you what is favorable outcome here. Here, favorable outcome is what? Here favorable outcome is nothing but getting ahead. Okay. So number of favorable outcomes we represented by n of s. N of s like this. Okay. N of s means this is cardinality of s. Okay. This is for this one. N of e. Okay. N of e is what? Okay. N of e means number of favorable outcomes. Okay. N of e means this is n of e. Okay. We represent this as, see here, I'll write it here. We represent this as n of e, that is cardinality of e divided by n of s. N of s means this is nothing but sample space. Cardinality of e divided by cardinality of s, that is favorable outcomes. What is the favorable outcome? That is number of favorable outcomes, that is n of e, number of favorable outcomes of the event divided by total number of outcomes, that is total number of outcomes is represented by n of s. Because we know the total number of outcomes, that is nothing but set of all possible outcomes, that is equal to sample space. So here, if I write P of E, okay. So here, what is the sample space, friends? Here, what is the sample space? Here, the sample space is, when it comes to tossing a coin, we can get head or we can get tail. Okay. So P of E is N of E. Here, N of E is how much, friends? N of E is nothing but, here, getting a head means only one head. So it is 1. Here, N of S, cardinality of S, is how many outcomes are there here? 1 and 2. That is head and tail. So it is 2. So your probability is n of e divided by n of s. So out of sample space, there is only one head. So that is n of e is 1. Sample space, there are sample space, how many number of sample space? In a sample space, how many these are there? How many outcomes are there? There are 2 outcomes, identical. So that is n of s. So that is 1.2 or it is 0.5. Okay. So this is the meaning of probability. So probability of an event, okay, probability of an event always lies between, it is always greater than or equal to 0 but less than or equal to 1. In terms of percentage, it is greater than or equal to 0%, 0% but less than or equal to 100%. Okay, it can never be negative. Okay, suppose you are getting 1.2 as probability in any question, that means you have done completely wrong, because probability always lies between 0 and 1. It can be 0 or it can be 1, but it can be never be greater than 1 or it can be never be less than 0. That is, it cannot be negative. Got it, friends? I think there is one question here. So the question is, what is the probability of getting even numbers of throwing a dice? Okay. So here the event is what? Event is what? The experiment. What is the random experiment? Random experiment is throwing a dice. Event is what? Getting getting an even number. Getting an even number. Okay, getting an even number. Okay. Here sample space is what, friends? When we throw a dice, we can get 1, 2, 3, 4, 5, 6. Okay. Out of this, what are even numbers which are divisible by 2? 2, 4, 6. So getting an even number, what are the favorable outcomes? Favorable outcomes are 2, 4, 6. Okay. So for this, if I write cardinality of E, that is n of E, here how much is there? 1, 2, 3. Okay. For this, if I write cardinality of S, that is n of S, here how many we have? 1, 2, 3, 4, 5, 6. So total sample space is, that is 6. Okay. So now probability of E. So probability of E is nothing but number of favorable outcomes, that is n of E divided by total number of outcomes, that is n of S. So that is equal to what, friends? 3 by 6. That is equal to 3 1s are 3 2s are 1 by 2, or it is 0.5. So the correct answer here is C. Like this, we have to solve this question. Got it, friends? Like this, we have to solve this question. Next, I hope now what do you mean by probability is clear to you. The definition of probability, how to find the probability, I hope it is clear. Now let us move to the addition theorem. Okay, suppose A and B are two events. Suppose A and B are two events. Okay, addition theorem says A union B, P of probability of A union B. A union B means combining A and B. Okay, probability of A union B means probability of A plus probability of B minus probability of A intersection B. Okay, so this is the theorem when it comes to two events. Okay, if there are two events, probability of event 1 and event 2, I can write it here in the form of two events. Probability of event 1 union event 2 will be equal to probability of E1 plus probability of E2 minus probability of E1 intersection E2. This is nothing but formula you have to remember, that's all. While solving the questions, this is very important. This will be very useful while solving a lot of questions. That is addition theorem. When it comes to two events, this is the formula. Okay. When it comes to three events, that is A union B union C, that is E1, E2, E2, E3. That time it is nothing but probability of A, probability of B plus probability of C minus probability of A, B, C is there, right? Probability of A intersection B, B intersection C, and C intersection A. Okay. Plus A intersection B intersection C, probability of this. Okay. So one thing you must understand here, probability of A intersection B is same as probability of B intersection A, or probability of A intersection C. You can also write it as it is same as probability of C intersection A. There is nothing different in that. Suppose I ask what is common between A and B. It is same as asking you what is common between B and A. Suppose I ask what is common between A and C. It is same as asking what is common between C and A. So I can write it like this. This you have to remember. So these two formulas, it is highly important. You have to remember. Basically, they ask for two events, but in some cases they may ask for three events. So if they ask for three events, you have to remember this formula, second formula. So first and second formula you have to definitely remember. Based on that, they're going to ask the questions. All right, friends. So let us move forward. This is the addition theorem. I hope it is clear to you. See here, look at this. This is a previous year question. IIT JAM 2024. This question was asked. Okay, IIT JAM 2024. This question was asked. Okay, this is a PYQ. Most of the questions we have taken is PYQ. Two dice are rolled together. The probability of getting a doublet or sum of faces as 4 is. Okay, so here one thing you must understand. When it comes to sample space, see here, we're having two dice. Here we're having two dice. Okay, listen carefully. This is two dice. Here, this is one die. Okay, this is one die. Okay. But before that, I want to tell you something about dice here. Dice. This is representing 1. This is representing 2. This is representing 3. Okay, and this is representing 4. And this is representing 5. Okay, and this is representing 6. This is 1, 2, 3, 4, 5, 6. So your sample space is what, friends? Same thing. That is 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. This is when it comes to one dice. Suppose there are two dice. What is the sample space? Two dice. What is the sample space? For one dice, it is coming up to 6. Correct? No. N of S is coming as 6. Okay. Number of sample spaces coming as 6. For two dice, N of S is nothing but sample space. Single for one dice, what is the sample space? To the power of n. So for two dice, n of s to the power of n. This n is what? This n is nothing but number of dice. This n is representing number of dice. Here it is equal to, here it is 2. So this will be equal to what? 6 to the power of 2. So this will be number of sample space will be 36. So suppose it is 3 dice, it will be number of sample space will be 216. Suppose one coin means sample space will be equal to what? Sample space will be equal to head comma tail. Okay. Okay. Suppose two coins. So here n of s is what, friends? Here n of s is cardinality of s is equal to 2. Suppose two coins are there, then cardinality of s will be equal to what? This is 2, right? This is 2 to the power of n. Here n is representing what? Number of coins. So it is 2 to the power of 2. So it is sample space is 4. Okay, if 3 coins, 2 to the power of 3, that is 8. Got it, friends? Like this we have to find. So in the given question, they are telling, two dice. So this will be having 6 as the sample space, n of s will be 6. Here also this dice will also have 6 as a sample space. So 6 into 6, 36. This is one way of finding. Another way is like I told, n of s of for one die. One die will be equal to 6. For n number of dice, it is 6 to the power of n. Here n is equal to 2. So 6 to the power of 2, here it is 36. So n of s is 36. Now they are telling two events. Okay, they are telling two events. So before that, before that, I would write total number of outcomes. Okay, total number of outcomes is 36. But how do you get it? So I would write sample space. Sample space for how many days? For two days. For two days. This will be like this. Okay, like this will be like this. Here, let me fix the first die. In the first die, let the face be 1. Okay, let the face be 1. So 1. The second die it will be 1. 1. Second die it will be 2. 1, 3, 1, 4. Okay, 1, 5, and 1, 6. Now, the first die, let me fix the face to be 2. So 2, 1, 2, 2. Okay, 2, 3, 2, 4, 2, 5, and 2, 6. Now let me fix the face of the first die to be 3. 3, 1, 3, 3. Okay, 3, 2, 3, 2, 3, 3. Okay, this is 3, 4. This is 3, 5. And this is 3, 6. Next is, let me fix it to be 4. 4, 1, 4, 2, 4, 3, 4, 4. So initially for your understanding, I'm writing, but in the examination, you can do it very fast with more practice. Okay. So this will be, let me fix it to be 5, 5, 1, 5, 2. Please listen carefully, 5, 3. This is a very important question. This has been asked previously, that is IIT Jam 2024. 5, 5, 5, 6. Okay, this is a simple question, but it appears a little complex. But let me fix it to be 6. But with more understanding, with my explanation, you'll be able to understand. 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Now here, this is the sample space. Okay, so this row we are having 6 and columns we are having, the row we are having 6 and columns we are having 6. So 6 into 6 is 36. So these are all what? All possible outcomes. All possible outcomes. This n of s will be equal to, if you count this, you will get it as 36, friends. That is what I wrote here. For 2 dice, 6 power 2. For 3 dice, 6 power 3. Okay. So now, what is the event that they are telling? The 2 dice are rolled. The probability of getting a doublet or sum of faces as 4. Okay. The probability of getting a doublet or sum of faces as 4. First thing they are telling is doublet. Okay. Getting a doublet, this is event 1. This is one event. Or sum of faces as 4. Sum of faces as 4. This is event 2. Okay. There are two events here. Okay. You have to round it off to 2 decimal places. That we'll see later. So there are two events. So first thing you must understand. See here. When they're saying or, that means what? That means they are telling union. That means they are telling union. When they say and, that means they are talking about intersection. That means they are talking about intersection. Or means union. They have to combine. And means intersection. You have to find the common thing. Okay. So here, what are the two events? Event one is event one is event one is getting a doublet. Getting a doublet. Okay. I'm explaining in detail for your understanding, but while solving the examination, directly you can solve. No need to write all this. Event 2 is getting sum of faces as 4. Sum of faces as 4. Okay, getting sum of faces as 4. Now, first of all, you have to know, most of you will not be understanding what do you mean by doublet. Doublet means both the faces you are getting same number. Both the faces getting same number. How many are there here? Suppose same number means 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 5, 5, 6, 6. Like that means, see here, this is the thing. Okay, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So see this diagonal. This diagonal, you are getting it. So how many are there? Okay, I can write it here. Getting a doublet. Event 1 getting a doublet. That is nothing but that favorable outcomes is nothing but 1, comma 1, 2, comma 2, 3, comma 3, 4, comma 4, 5, comma 5, and 6, comma 6. So friends, here n of what is this? N of even. N of even is how much, friends? N of even is 1, 2, 3, 4, 5, 6. This is 6. Okay. Next, getting sum as 4. Getting sum as 4 means the only possibilities is, see here, if you look at this diagonal, if you look at this diagonal, see here, look at this diagonal here, look at this diagonal here, this and this. Only possibility where you get sum of faces as 4 is this one. See here, 1, 3, 2, 2, and 3, 1. Other, you can't get sum of faces as 4. That is, sum of the two faces, if you have to get it as 4, the only possibility is 1, 3, 2, 2, 3, 1. That is equal to 1, 3, 2, 2, 3, 1. Got it? So this is n of E2 is how much, friends? N of E2 is how much? 1, 2, 3. Okay. But one thing you must understand, one thing you must understand here in both the cases, n of S is how much? Sample space. N of sample space is how much? We got it as 36, friends. We got it as 36. Here they're telling the question that they're asking is the question that they're asking is probability. The two dice are rolled together. The probability that getting a doublet or sum of faces as 4. Doublet or sum of faces as 4. That is, or means even intersection, not intersection, even union 2. Okay. That is the question that is asking is that they're asking is P of even. Even is what? Getting a doublet. Or means union. Okay, union. E2 means getting sum of faces as 4 is we have to use the formula. As per this, we know that because we know that P of A intersection B, not intersection, sorry, P of A union B is P, probability of A, probability of B minus probability of A intersection B. Probability of A intersection B. Okay, so first thing here it is P of E1, P of E2, okay, minus P of E intersection E2. Now, see here, one thing you must understand here, E intersection E2. Let us find out. E intersection E2 is what? That is there anything common here? Is there anything common here? Yes, there is common. That is 2 and 2 are common here. So E1 intersection E2 is nothing but we're having what? We're having 2 comma 2. Okay, 2 comma 2. So n of E1 intersection E2 is what? It is nothing but 1. It is nothing but 1. So now let us find probability of E1. Probability of E1 is what, friends? Probability of E1 is nothing but n of E1 divided by n of S. That is nothing but n of E1 is 6 divided by 36. Don't cancel it now. We can do it later. Simplify it later. P of E2 is what, friends? P of E2 is 3 by 36. That is n of E2 divided by n of S. That is 3 by 36. Next, probability of E1 intersection E2 is nothing but n of E1 intersection E2 is 1 divided by n of S. That is 36. Okay. Now, if you substitute these values in this formula, in this equation 1, what will get? P of E1 intersection, sorry, union E2, we get it as P of E1 is what? 6 by 36 plus P of E2 is what? P of E2 is 3 by 36 minus P of E intersection E2, we get it as 1 by 36. So 36 is the denominator, that is LCM, same. So 6 plus 3, 9. Okay, 6 plus 3 is what? 9. 9 minus 1 is 8. I'll write it down. 6 plus 3 is 9. 9 minus 1 is 8. That is 9 minus 1 divided by 36. That is nothing but 8 by 36. So if you cancel this, 2 4s are 2 18s are 2 2s are 2 9s are. So you'll get it as 2 by 9. So 2 by 9, if you do it like this, if you do division like this, okay, if you have to put 0, 9 2s are 18, again 2, okay, 2 will come here, okay, again 0 you put, 9 2s are 18, like that. So you will get it as 0.22. You'll get the answer as 0.22 rounded off to 2 decimal points. Suppose in the next decimal you are getting 5 and above. 5 and 5 above 5 means you have to write 0.23. If you're getting less than 5, you have to keep it as 0.22. Here you will keep getting 0.22222. Okay, so we have to reduce it to 2 decimal points. So this will be equal to how much, friends? Here the answer is 0.22. Okay, please go through the explanation again. Okay, please go through the explanation again. This is a very important question. So number of sample space. Okay, what is the possible outcomes when it comes to sample space? What is the favorable outcomes? That and all we have found out. And we have used addition theorem also. So using the addition theorem, we have to solve this question. So suppose if it is number of sample space is 6, but the dice is 1, so number of sample space will be 6 itself. Suppose the dice is 2, number of sample space will be 6 to the power of n, that is 6 to the power of 2. So number of dice is 3, 6 to the power of 3. Dice is 4, 6 to the power of 4. What is that? Number of sample space. Coins, when it comes to coins, number of sample space we are getting is 2 for one coin. If it is 2 coins, it will be 2 to the power of n. N is 2. 2 coins, 2 to the power of 2. 3 coins, 2 to the power of 3. 4 coins, 2 to the power of 4. Like this we have to solve. Okay, so we have dealt some topics of axiomatic approach to probability. I told you it is very important topic. Okay, I'll wind up here. We'll continue in the next class. Okay, we'll continue from here in the next class. I hope the session was useful. Please like and subscribe, and please answer the questions in the comment section for which are the questions which I have asked. Okay, all right, friends. Okay, thank you so much for attending. Let us meet in the next session. Take care.